Hello and welcome to our first video on Advanced Trig. My name is Mr. Chowdhury and we're going to be looking at a Pythagoras recap. Now if you are not so confident with Pythagoras and you're not really sure about it, the best thing to do is to watch our Pythagoras playlist, and that will help you get to grips with Pythagoras before you come to this one. I'll put a link in the description and on the slide. So here is your first task. Here's what I'd like you to do. There are some triangles there. Each triangle has three sides, obviously, and on those three sides there are squares attached to them. What I would like you to do is find out the area of each square and tell me what you notice. So you find out the area of each square and tell me what you notice. This is where you'd pause the video and have a go. Right, so if you've done that correctly, I'll go through the first one for you and I'll just pop up the answers for the rest of them. This first one is a 4 by 4 square, very straightforward. So that means the area of this square is 16. This one is 1, 2, 3, 4 full squares and then a half there. There's a half there and a half there, which makes a whole. Another 2 halves, another 2 halves, and another 2 halves. So this one adds up to 8. This one adds up to 8 as well. And that's that question done. Let's have a look at the second one. The easiest ones to work out would be these two. So this is obviously 4 and this is obviously 9. And this one, we just need to do a bit of counting just to figure out where we're at. Just find the little pieces that match up to make little squares. And we end up with 13. Now if you do the rest of them, this is what you should have got. And the question was, what do you notice about the sides? And what relationship can you draw from it? Now here's a right angle triangle, and the relationship I was looking for you to draw in words is this one, that the sum of the squares, like in the last slide there were squares on each side, the sum of the squares of the shorter sides are equal to the square of the longest side. Now that is Pythagoras in words. That's what Pythagoras Theorem is if you wanted to describe it in words. In algebra it would look like this, where A and B are your shorter sides and C is your longest side. So that is Pythagoras Theorem. That's how you would find it. That's what we are doing. That's what we're working with. Before we move on, just need to give you a keyword. Your keyword being hypotenuse. The hypotenuse is the longest side of a right angle triangle. Hypotenuse is the longest side of a right angle triangle. It's really important that we use mathematics vocabulary where we can. So hypotenuse, longest side of a right angle triangle. So before we can answer any Pythagoras questions, we need to be able to correctly identify where the hypotenuse is so that we can use the formula to the best of its ability. So here's a right angle triangle. Within right angle triangles, the hypotenuse is always going to be opposite the right angle, because in a triangle, the biggest angle is always opposite the longest side. So here's my hypotenuse, opposite the right angle, that's what we're looking for. So opposite the right angle, and we'd label that C. Now the other two sides do not matter what we label them. We could label them A, we could label them B. I've just gotten with this way, that one's A and that one's B. It doesn't matter, it could have done it the other way around, and that's because addition is commutative. We're going to end up adding these squares. Like when we square these, we're going to end up adding them. So it does not matter which way around we add them, because if you think about it, 3 add 4 is 7 and 4 add 3 is 7. So it doesn't matter which way around we do it. So labeling these is not as important as labeling the hypotenuse. I could have labeled this one B and this one A. It does not make a difference. So for this one, there's my hypotenuse and there's my A and B. I'd like you to pause the video and have a go at the others, and we'll come back with the answers in a sec. Okay, so if you've done this correctly, you should have noticed there's my right angle, there's my hypotenuse, label the other two A and B. This one, there is no right angle. So that means this triangle, although it looks right angled, is not a right angle triangle. So we cannot apply Pythagoras. Just because something looks right angled doesn't mean it is. We need to make sure that it has an indicator of a right angle in there. This one, the last one, there's my right angle, opposite is C, and I label the other two A and B. Now we need to learn how to use Pythagoras formula. Okay, so now that we know how to label the hypotenuse, we're going to be looking at how to use Pythagoras theorem and how to use the formula to solve some questions. So here are two questions that I've done for you. The working is correct, the working is there. What I'd like you to do is tell me what's the same and what's different, and then try and explain why we did each step. So the first thing, the key thing, is to find out what's the same and what's different in these two questions, and then talk me through the steps. Okay, so let's have a look at these two questions. What is the same and what's different? Well, we can say that the triangles are both right angles. That is definitely the same. We can also say that the triangles are exactly the same, because if we look, the answer for C here is 5, and we can see that C here is 5 as well. And we can see that A is 3, and we work out the answer for this side, A is also 3. So these two triangles are exactly the same triangle. They're exactly the same triangle. Now the difference is, there's one key difference that I wanted you to focus on, and that key difference is, over here we're looking for the hypotenuse. We're looking for this long side. Over here we're looking for a shorter side. And that's the key difference between these two questions, is one of them we're looking for the hypotenuse, and the other one we're looking for a shorter side. That's the key difference between these two. So now let's look at the working. Let's look at the similarities and differences in the working. So the first step, what they have done is they've written down Pythagoras Theorem. They're both the same, so I think that would be a really good step to write down. So step 1 would be to write down Pythagoras Theorem. We do this because as we build confidence, you won't have to write Pythagoras Theorem down, but to begin with, it's useful to write it down so that the rest of the steps become easy. The next step, they've substituted the values. So they've replaced the A, the B, and the C with the values from the question. So for example, on this question, they've replaced A with 3, B with 4, and C with X. And on this question, they've replaced A with X, B with 4, and C with 5. That's what they've done. Now the next step looks slightly different. They've squared everything, but on this one, X is the subject, but on here, X is not the subject. So they have squared. So here they've squared 3, they've squared 4, and X has obviously been squared here. Here they've squared X, they've squared 4, and they've squared 5. However, as I've said, over here on this left-hand side, X is the subject of this equation, whereas X is not the subject of the equation here. So what they've had to do on this right-hand side is add an extra step to make X the subject, so that they can follow the rest of the steps. So on the left-hand side, because X is already the subject, they've added these two numbers together, which gives me 25, and they've square rooted both sides to get X as 5, and this is our answer. On the right-hand side, once they've made X the subject, once X was made the subject, then they've done the calculation, 25 minus 16, which gives us 9. Then they've square rooted both sides, and they've got this answer here. So the key difference to denote from this question, from these examples, is that when we are looking for the shorter side, we may have to do an extra step of rearranging the equation. That's something that we won't have to do if we're finding the hypotenuse. If we're finding the hypotenuse, we can just add them and square root. We can square, then add, then square root. However, if we're finding a shorter side, we end up having to square, do some subtraction, and then do a square root. So there's an extra step on finding the shorter side. Hopefully that helps. You can always come back to this slide if you are stuck on a question in the future and look back at the working just to see what you're doing. It's really important that you have worked examples with notes so that you know exactly what each step was done, because that's the key, is having these notes. When you look back at this, the notes will be more useful than the actual working. Right, so before we move on, you are very rarely going to be given a question where it just gives you a right angle triangle and says find the missing side. That's not what usually happens. Usually, you're going to have to try and figure out where the rat is, or you're going to have to try and find the rat. So here are some shapes, and we're going to try and find the rat for each one. What I'd like you to do is draw in a line, or more than one line, to show me where you would find some right angle triangles. What could we do to find a right angle triangle? So I'll help you out with the first one. So this first one, an equilateral triangle. If I wanted to find a right angle there, I would just drop a perpendicular and I have two right angles, and that will help me work out the answer to a question that may require me to use Pythagoras. I'd like you to have a go at the rest of them, so pause the video, have a go. Where would you draw the lines to help you find the rats? Where would the rats be? Okay, so for this question, once again, we just drop a perpendicular. That will help us find out the right angle. For this square, if we drop in a diagonal, we can see we produce two right angle triangles. For this rectangle, similarly, we drop the diagonal in the opposite direction. It does not matter which direction you drop the diagonal, you'll still get a right angle. For this trapezium, for this right angle trapezium, we can drop perpendicular there. That will give us a right angle triangle and a rectangle. For this isosceles trapezium, you can do that. That will give us two right angle triangles either side of this rectangle. And for this one, you could do that. Now, in this picture, it looks like this is a right angle. However, because we're not told that this is definitely a right angle, we cannot just draw this line in and say, yep, that's a right angle, just because it looks like it. It's not a right angle unless we have done it through geometry. Right? So what we need to do for this question, because we're not sure if this is a right angle, is draw another line in. And then you end up with a right angle here and a right angle there. Hopefully that's been helpful. What I advise you to do now is to go on Corbett Maths or Dr. Frost and practice some questions. You can always come back to this video and have a go. The key things to denote from this was what Pythagoras theorem is. It's about squaring the sides of a right angle triangle. So you square the shorter sides and then add them together, and that will give you the square of the longer side. So that means if you want to find a length, you need to remember to square root and discover where the rats are. Like, these are the two key things. The working is there for you. You can always come back and look at it. Hopefully that's helped. There will be more videos in this series that cover the recap, that cover these. Once again, I'll remind you that if you are not too familiar with Pythagoras and you want a little more extra help, there will be a link to the playlist on Pythagoras Theorem to give you that extra bit of help. Thank you. Have a wonderful day. Be productive, and I'll see you again.